neglected. So we have two active forces, one P1 equals P second equal 20 kilonewtons. So always remember the units of the force, right? And the dimensions of the beam AB are shown in this figure. So maybe this 2 meters, 3 meters, and 2 meters, right? So let us determine the reaction of the fixed pin A and roller support B. This problem is very simple. Why? Because it's only about one part. You see, there are only one part AB has two types of constraint with the fixed body or the frame. So if we want to get the answer of this problem, we should first, according to the type of constraint, give the force analysis, right? So maybe I will change my pen into another color to show you guys how to do this. And use maybe color green, okay? So because you guys know, actually this is a fixed pin A, right? So in order to save our time, I will just give the reactions on the original picture. So actually we should remove this constraint and using the reaction forces to replace its action to this point A onto part AB, right? So we will draw like F, maybe FAY, and FAX. And at point B, we know that a type of constraint is roller support. That means this type of constraint, it will allow this part to move along X directions. So it only have one direction of reaction force. So we can draw this like, it's very hard to draw vertical line, let's say FB. Right? So you see, actually this force analysis is very simple. You just need to according to the type of the constraint and give the reaction force here. Then we should try to figure out its value, right? So actually for coplanar, coplanar force system, we talk about its equilibrium condition. We will have three equations, right? Just sigma x equals 0, sigma y equals 0, and we can arbitrarily select any point on this plane. We do not must select points on part AB, but in many cases, we will just select the point on the part, right? So we can select a point like point A, give this equation sigma MAF equals 0. That means all the forces acting on this part, its sum of moment to point A also should be 0 if it is under condition of equilibrium, right? So actually, I hope you guys can solve this problem by yourself because it's quite easy, right? So let's do this together. I hope you guys can totally understand, right? So the first one, actually, if I myself to tackle this kind of problem, usually I will select this moment equation to be the first. So maybe I will just like this solution, right? Sigma MAF equals 0. Why I select this equation to be the first one? So I think the reason is because FAY and FAX, its value is unknown. But when I do this MAF, we know actually FAY, FAX, its action line are all through this point A. So that means MAFAY and MAFAX are all 0. So we only need to consider P1, P2, and this FB. So we will find actually through this equation only one unknown value. So we can just use one equation to find the absolute value of FB. So actually that is the basic rule. We better just use one equation to solve one unknown at a time, right? So let's see. So before we do this equation, maybe I should review the moment of false to a point with you guys. Do you guys still remember when we talk about like MAF? We talk false is moment to point A. So usually let's say P1, right? Usually actually is equals R 1 equal cross products P1, right? So actually we need the link A and action point of this false P1 at C. So actually AC is position vector of this false P1, right? Actually, we know that two vector is cross products. The result will another vector, and because our problem is in the plane, coplanar force system, so this will be easy to calculate its result because we know that from mathematical knowledge point, it will be the absolute of vector AC times absolute value of force P1 times sine actually R and P1. So this means the intersect angle between this position vector and this force vector, right? Because it all happens on a same plane. So actually, this just need to use maybe I can redraw P1 here, but it's hard because we can freely move a force along its action line, right? So actually, we have this. Actually, this equal 2 times S triangle ACP1, right? ACP1. So I think like this P second, so we should, in the plane system, we should always decompose this force P1 into two directions, which is P1X, another is P1Y. And we will always find actually, and each time P1X will have 0 moment to this point because it will always through this point, we want to calculate this moment. So we only need to consider P1Y. So actually this P1 interaction line is totally along the vertical of the direction of Y-axis. So this one will be 0 and this one just equal P1. And another thing you guys should remember, always remember that we have right hand rule to figure out its direction. So I will repeat this. Actually, I said this many times. You guys should always remember that. So first, we use our 4 fingers. Our right hand 4 fingers. That is direction along the direction of position vector. In this example, it's R1, right? Then we should fold our 4 fingers. Try to let its 4 fingers this time along the direction of P1. then you will find actually this moment P1 to A, actually it will have this direction, which is CW, clockwise, right? If this is the case, then our MAF, actually MAP1, should have a minus sign, right? Another time, if you find another force, moment to this point, its direction is another direction. So maybe I draw like this. We call that CCW, counterclockwise. Actually, in Chinese, we call that 逆时针. So this time you'll find it should have a positive sign, right? So about the moment of a force to a point in the plane, you guys should remember this. Especially this sign. So if you cannot figure out the correctly sign should be, maybe your result will not correct, right? So since I draw a lot of green color sign on the screen, so I will rechange my pencil color. So let's do this equation together from left to right. So because Fey, Fx, we do not need to consider that. So we first will consider P1, its moment to point A, right? Actually, we have the conclusion. Actually, this moment of P1 to A along CW direction. So we have minus P1 plus its distance from A to C, actually the second, right? And here we have P second, actually is not on vertical line, but we can use the method to find its P second X and P second Y. So actually, because this color is, we can write here, P second X should equal P second. Because here the angle 60 degree, and here also should be angle 60 degree, cosine 60. And actually its direction is opposite from the positive direction of x-axis. So we have this should be minus. You also can you just write here its value because you know or you know its direction here. So you can just use its direction to figure out what its moment to point A its direction, right? And P to Y should equal what? So P to Y should equal P2 times what? Times sine 60. See? Actually, this one is along the negative direction of y-axis. So this time, because P, actually this point is action point. So we always do not need to consider its x component. So we can find actually P second y have the same direction with P1. So its moment to point A also is CW direction, also should be minus. So we have minus P second sine 60, right? And times the total length, the whole length of this. So should times 5. Then we only need to consider this FB. So it's very easy. You can find actually FB, its direction is opposite from P second Y and P1. So actually this force is moment to point A is along the CCW direction, which should give a positive sign. And its magnitude should be FB times the whole length of this part. So we have 7 equal 0. See, this is all about the sigma MAF equals 0 because all the things is known. So we can get the result of FB. So let's do it together. So we have this is 20, so we have minus 40, right? And this one P2 is 20, sine 6 should be square 3 over 2 times 5 and plus 7 times FB. So after we have this, we can just use our calculator of software to find its result. So we will find actually, so first we will do is minus 40 minus 20, I'm sorry, minus 20 times third, I'm sorry, third, right? 20, that is third, that's squared 3 over times 5 over 2, right? And we only need this one, A and this one, A and S over 7. Over 7, we will get. Actually, we will find actually this manner sign it do not need. Actually, the true answer of FB should be 18.0861. Can you guys understand me? Can you guys understand that?
Yes, Alash.
Okay, so actually FB equal 18 0 8 6 6 1 kilonewtons, right? That's what we found from this equation. After we do that, actually the other thing is very easy. So we can use sigma x equals 0. So because we assume that this FAX should along this direction, so we can just write that FAX. This one P1, it have no component along x-axis, so do not need to consider that. So we have P second x, but its value is P second times cosine 60, but its direction is along the negative direction of x-axis. So you should give a minus sign here and P second cosine 60, right? And this FB have no any effect along x-axis. So actually we can find FAX should just equal P second. So that means FAX should equal 20 times, I think cosine 60 should be a half, right? So it's just, we can find its result will be 10 newtons, right? Then we only have one left. So we can once again use the third equation, sigma Fy equals 0. So this time you guys can look at this figure. So we will write like Fay minus P1 because its direction along the negative direction of y-axis, and minus P second y. So minus P second, because we have its value here, sine 60, and plus FB equal 0. You see? When you give this final equation sigma Fy equals 0, you will find actually FB we have known its value. So P1, P second all are 20. So we can easily find this FAY, right? That's the whole answer of this question. This page is the last time I give the answer to my student, so you guys can check that. So we have FB equal here, right? FAY should be 19.24 kilonewtons. And what about FAX? FAX should be 10 newtons, right? FAX here is 10 newtons. So I hope you guys can totally understand what I'm talking about. I try to slowly my speed. I try my best. I'd like. I hope all you guys can finish this kind of problem. Actually, this is very simple, you know. So after talking this homework, we'll move into the example. Actually, this example is talking about body system. Body system. No body system. So you will find actually this system is quite complex compared to the homework we just finished, right? So you guys can focus on this figure. It tells us let's OA. Actually, OA is 2 points on this wheel. As a circular wheel, it can rotate around the point O, maybe because of the direction of this moment M, it rotates at CW direction, right? So we have OA equal R, AB equal L, and the pressure force to be P. So there is a resistance force. It is the active force P. So after when this wheel rotate around point O, and this point A, actually this AB will move along about this direction, and they will let this slider to move along the vertical line. So actually this is so-called body system. It has two parts. So we call 1 second and 3. So it's very obvious there are 3 parts. Why I said this body system consisted by 4 parts. So always remember we also have another part which is frame. Right? Like ground, it will not move. Frame. Right? It's always fixed. So actually you can find at point O, at point B. We have 2 constraints between one of part of the system and the ground of the frame, right? And at point A, we have a constraint between part 1 and part 2. And at this point, we also have another constraint between this rod AB and this ladder 3, right? This is so-called body system. So let us determine that 1, 2, 3, 4 questions. So if this body system is in the condition of equilibrium, let's find the value of M, right? And second, the reaction forces of point O, and the internal forces of rod AB, the side pressure acting on the lead reel, right? Maybe you guys will find this is quite complex than the first one we just finished. Actually, we should find some clue to try to figure out the questions out. So actually, do you guys still remember when we encounter a part from a body system? So if we we can look at this bar AB. So it's straight line actually only have forces at point A and point B, because there are no gravitational force acting on this bar AB. So although it's not tell us, we can neglect the weight of AB, but it not give its gravitational force here. That means we do not or we neglect its weight of AB. So it will have a hint. Do you guys remember? It will give us a hint. This rod AB will be a double force bar or double force balanced bar, right? Maybe it will be pushed together at point A and point B, or maybe it will be pulled from A and B, right? And all these force actions, action line will along the link line between A and B, right? So that's a very important clue for the whole system. So let's see, because we know that AB is the 二力杆, right? So you guess we just follow the process of its solution. So first you said us study the point B. Actually, it means we select this letter B is an object to be studied. You know, when we see the whole system is in a condition of equilibrium, then when we select one of part or some part of this whole system, it also should be in the state of balanced, right? So we should imaginary we free this letter B from this whole system. But we should, because it's an assumption, not for real, we should use the reaction force accordingly to replace the action force of all the other part to this slider B. So you see, actually, its force analysis is like this, right? We think about it, we imaginarily think that we free this letter from this whole system to here. So actually, all the constraint acting on this letter B is removed, but we should use reaction force accordingly to replace its action on this point, on this letter B, right? So you guys look at this. We remove the constraint from AB to this letter B. So because we know that AB should be a two force balanced bar. So we see if we draw this SB, it means there is a force along direction of AB. Actually, this SB is the force acting by AB to slider B, right? And this is active force. It is known on the system. So we have vertical direction of P, and another actually is the reaction force from this so-called what? So-called lead rail, 导轨, right? Lead rail in Chinese, we see that 导轨. So its function is like this ladder only can move along the vertical line, right? So this lead rail will have a reaction force along this direction. So you will see. We study the point B, I'll study the letter B as an object to be studied. Then it should be in the state of balanced. And there are three forces acting on the same point. You see, actually it is what? Planar concurrent force system. 平面汇交力系. Can you guys understand? Can you guys understand this force analysis? Can you? Please, you guys replies to me. Are you guys still listening to me? Am I just talking to myself? No, no any reply. Hi, what are you doing, guys? Right? So actually, this just a very simple planing coplanar concurrent force system. So actually it have two equations if it's in the state of equilibrium. So one is sigma x equals 0, another is sigma y equals 0, right? So from the sigma x equals 0, we can find, see, actually we give the default coordinate system. So positive x direction will point right, right? And what upward is the positive direction of y-axis. So when we give this equation sigma x equals 0, you can find from this very simple force analysis figure. So we have n, because this direction is along the positive direction of x, so it is a positive sign. And SB, because we know that this angle is alpha, so we have SB. I always give myself a 8 line. So this angle is alpha, so this angle also should be alpha because my 80 line is parallel to y-axis. So I can see from this 80 line that SBY will be SB times cosine alpha along the negative direction of y. And SBX actually should be SB sine alpha, and it will along the negative direction of x. So we have a minus sign here. So we have n minus SB sine alpha, right? So actually we have here OA is length is R, AB is L. Actually we can find sine alpha equal R over L, right? So we can find this N and SB, the relationship between N and SB, but N and SB are two unknowns. So we cannot figure out its value from just one equation. So we should give another equation that is sigma y to 0. Guys? So once again, we see this figure. So we have P. This P totally along the positive sign of y-axis. So we have positive P. And SB times cosine alpha, its direction will along the negative direction of y. So we have minus sign here. And if sine alpha equal R over L, then we can find actually cosine alpha will equal LOB over L, right? So actually this sine alpha and cosine alpha is known. So from these two equations, we can find actually SB equal P over cosine alpha and N equal P times tangent alpha. So you see, so we find the slide pressure acting on the lead reel, actually this. And the internal force of rod AB actually is this. You guys can figure out why it is this. Because we know that rod AB should double force. Then we can just study the wheel. So maybe I should explain for you guys here. So if when we select this letter B as an object to be studied, so if we see this ISB is acting by rod AB on point B on the slider B. So actually from the action and reaction force, that means this AB, it will be pushed along AB direction. So we have this SB prime, and here is SA prime. No, so that means that the magnitude of SB prime and SA prime will equal SB. And once again, when we select the wheel to be studied from the action and reaction force, we also have this. So that's why we have another SA. Actually, it's SA prime is another pair of action and reaction force. all because we think that AB should be pushed at here with SA prime and pushed at here with SB prime. No, this rod AB is false analysis, right? So then we can select the wheel to be the object to be studied. So it's just a coplanar force system, right? We have three equations. One is because we try to figure out this reaction force from this fixed support that is between the part 1 and the frame 4, right? We have x0 and y0 or xo and yo. So we give this moment equation. So sigma MOF equals 0, then we can find. So all these two forces do not need to consider because it's moment to point O always equal 0. So we have, we have that this FSA. So maybe we can just elongate its action line, and we know it have an angle, right? It have an angle. This angle should be alpha, right? This angle, from here, it's quite hard, and here, because here is alpha and here also should be alpha, right? So we can give that SA times cosine alpha. So because this is SA, so SA times cosine alpha actually is a component of this force SA along this direction. Another is, I'm sorry, SA cosine alpha. This should be, let me see. This is SA. Actually, we also can think this like that. So if we draw a added line here, no, actually this is H. So if here is R and here also should be alpha, right? And we have that this H equal R times cosine alpha, right? In China, we call that this Li B, right? That is the point we want to calculate its moment to this point. It's distance from the action to the action line of the force. We call that dB. So we have this equation, this moment should be SA times R times cosine alpha, and its direction will be CCW, counterclockwise. So this part will be positive. And we try to figure out the value of M, but it's along CW direction, clockwise direction, so it will have a minus sign. So that's the whole sigma MOF equals 0. So we have this. Then we can find actually M equal SA cosine alpha R because we have the SA. Then if we try to calculate XO and YO, we can just use sigma X equals 0. You see? So we can XO along this, XO plus SA sine alpha, because this is SA and this is alpha. I made a mistake here. This is not SA, right? So SA should along AB direction. This is SA. So SA cosine alpha will along positive direction of Y. And SA sine alpha actually is along the positive direction of X. So we have this. We have this. And once again, we have sigma Y equals 0. So we have YO, right? YO plus SA times cosine alpha. So M equal PR. So X so from this equation we have M equal PR. Why? Because we have SA. We can copy SA's value from the last page. You know, we have SA equal SB should equal P over cosine alpha, right? So that means SA should equal to the P over cosine alpha. Actually, we have M equal SA times cosine alpha times R. So SA times cosine alpha times R. So this one will be eliminated, right? From numerator and denominator, right? So we have now this M equal PR. So we also have XO and YO. So actually, this is a typical example of a body system. So when I ask you guys a question, no one replied to me. Do you guys totally have no idea what I'm talking about, right? Does this example is very hard for you guys to understand?
Yes,
You?
Laoshi.
You cannot understand, right?
Yes, it's difficult.
It's too difficult for you guys, right?
Yeah, Laoshi.
Oh, so maybe I should not continue to talk about other example because it is too difficult for you. Actually, you can find we also have like examples like this, and this, right? Maybe it's too difficult. Actually, this one is another problem I just talk about with my Chinese student, but the figure is the same, right? So maybe I should not talk about with you guys. So then since you cannot think about very difficult example, let's say our textbook, we just select a single one, right? Maybe you guys need some time to read our textbook. See? I mean, actually, this is a very simple example, more like what? More like the homework we just finished discussion today. And actually, we are talking about equilibrium of a body system. That means the whole system will constituted by several bodies, right? More like this and this. I think so. Maybe I just use some paragraphs of our textbook to explain for you guys so-called equilibrium of body system. So I hope you guys can understand a little bit. So actually engineering, the actual object usually contains several bodies rather than a single part, a single body, right? So these bodies are connected together by constraints. You see, the whole system is an equilibrium system. So sometimes the loading information of each body in the whole system should be understood. That is, we not only care about the reactions of the whole system, but the forces from outside, but also the forces among the bodies of the system. Furthermore, we will study an equilibrium body system. So what is a body system? A system composed of several rigid bodies. Actually, each part can be treated as a rigid body, connected together by constraint. So actually, we have learned 5 types of constraints. So we knew we should be very similar from that 5 types of common type of constraint, and we can give the reactions accordingly. Before we begin, some concepts should be introduced. So let me introduce to you guys a little bit, right? I will try to slow my speed. Maybe it's too hard for you guys. So external forces. Actually, this concept you can think about the active forces. So forces which act on the body system from outside, such as gravity, external driving forces, or other applied load, right? So from this figure, we can find actually this gravitational force of this ball is W1 should be a external forces, right? And this gravitational force is W second of box B. It should be another external forces, external force or active force, right? And there are no any other external forces. So this is the first one. The second one is the internal forces. What does that mean? Forces among the bodies of the body system, you know, and they are the interaction forces between the two bodies. So you can see from point B, we have bar AB, we have bar BC. They are linked together through this point B by a what? By a pin, right? By a pin. We know that a pin is a very common. It is a very common constraint, right? It's a very common constraint. It will constrain the two capable of movement. That means if we select a B, wow, it's if we select a B, maybe this point B, right? And this point A. So we allow this to denote this bar AB. Actually, at point B, it will have two reactions. So maybe we have FBX and FBY. Why is this bar AB at maybe at point A? Because it's another fixed pin between bar AB and the ground. Grounded frame do not move, right? So it also should have FAX. And maybe like this. FAY. And this horizontal force F, actually it is the external force. We can also call that active force, right? This is point D. So actually, forces like FAY and FAX, FBX and FBY are the so-called internal forces. So it is time for us to have a rest. So you guys, we will have a short break. We'll restart it at 11. So we just select this figure to be example to discuss. Actually, to explain to you guys what is the body system, right? So I will try to let you guys understand a little bit. You see, actually the topic today, we are talking about the body system. What means body system? That means this is a plane system, right? So actually it has three parts. Let me denote for you guys. So we have part one, that is rod AB, right? We have part BC, given number second. Actually, we also have the frame third. So you guys should know frame. In Chinese, we call that 框架 or 机架. That means it never move. It's fixed, just like the ground, you know? So actually we see there are three parts. We always look at them as a rigid body. And you can find actually each part are connected with some kind of constraint with another part. So we can see at point A, it is a fixed support, right? We call that it kind of constraint. We call that fixed support. SUPPORT, am I right? Actually, it connected part 1 to part 3, right? So it will have some relationship between part 1 and part 3. So part 1 will have some action to part 3 through point A. Likewise, this part 3 also have some action to part 1 through point A, just because it's fixed support, right? And at point C, is also another fixed support. Let me just write it FS. It's between part 2 and part 3, right? And we also have at point B, it's a pin. It's not a fixed support. It's just a pin, right? Actually, it's between part 1 and part 2. You know, actually, we call that this is the whole body system, and it's in condition of equilibrium. And we just talk about two kinds of forces. One is external forces. External forces. You know, so when we select this whole part as an object to be studied, actually, so this F should be one of the external forces. And because we know it's in the condition of equilibrium, actually, we should remove all the constraints related with frame, right? So we can think about that. Actually, this whole bar AB and bar BC is fixed at point A and C. So it has relationship between the frame of the ground. So when we select the whole part to be object to be studied or researched, then we should just think about that we remove this constraint here and remove this constraint here. So then it will be like this. It is FAY and FAX. And here it should be FCX and FCY. So actually, all these four forces is acting by the frame or by the part 3 to rod AB and to rod BC. And actually, these four forces also are external forces, right? So all the forces, but the forces between AB and BC at point B, this time is internal force we call 内力, right? So because it has force acted by BC to AB, it also has another force acted by AB to BC. So these two forces will counterbalance to each other. So we do not need to consider that. So that is when we select the whole system to be studied, it force analysis will be like this. Then F, FAY, FAX, and FCY, FCS all exploded. So we should, based on these 5 forces, to give its equations like sigma x equals 0, sigma y equals 0, and some point sigma MAF. equals 0. And if we just select one part, ABC or AB to be started, let's see, if we select this BC, so I will try to draw BC here. So when we only select one part to be started, we should consider our imaginary thing that we free this part from the original body system. But we should give the force reaction force according to what? According to the constraint. So actually, we know here it also should have FCX, FCY, and at this point C and this point B. Actually, because this is a pin, right? So actually it should have FBX and FUY. So these two forces are acted by rod AB, right? Do you guys understand that? So because it connected by this constraint at point B from 1 to 2nd, right? So when we just select one part to be started, so it also should be to fulfill the condition of equilibrium. So we also have the equilibrium condition equation, sigma x equals 0, sigma y equals 0, and sigma maybe MCF equals 0. You know? So first of all, do you guys still remember, because this bar BC, actually it only have 2 points acting at B and C, and we do not consider it weak at middle point here. So actually it is what? It is a double force bar. So we can simplify its analysis like this. So if we see it will be pushed at 2 points, maybe this, so this B and C. So it will have FB and FC. So actually both force analysis, these and these are all correct. But this one is more simple because we know it is 二力杆 double force bar, and which we will know its action line, right? So actually you guys can find actually this FC is resultant force of this FCY and FCX. And this FB will be resultant force of FBY and FBX. So once again, if we select AB to be started, then we will find AB will not be a double force bar. Why? Because it has active force F here. So it also have another point, forces point A and point B. So it has 3 point acting point. So it should not be a double forced bar. So if you select these to be true, so you will, from the action and reaction point of view, give this FBX prime and FBY prime, its direction should be opposite from this one. So if you select this one to be the force analysis of BC, actually this one is highly recommended because it will quite simplify our calculation precise. So we will just see, draw like FB prime. So actually if bar AB push bar BC at point B, then bar BC will react bar AB along the opposite direction, right? And here we do not, we should copy this because it's fixed support between frame and bar AB. So it also should FAX and FAY. So actually, this is tell us how we do the force analysis to a body system. It will constituted by several parts. So we can select the whole part system as the object to be studied. We can select one part to be studied, and each part will be in the equilibrium condition. So we from this one, we also have sigma x equal 0, sigma y equal 0, and sigma m some point, maybe a f equal 0. Right? So if you guys can understand all these actually from some basic or simple body system, we can use this method to find some unknown. Right? So let's back to our textbook. Let's back to our textbook. So that is the external forces and internal forces, right? And let's continue to talk about if the body system is static, everybody in the body system is also in equilibrium. So here static means the body system in the state of stationary, not move. At the time change, it always keeps the original position, right? So everybody in the body system is also in equilibrium. That's why I told each one will have 3 equilibrium conditions, not conditions, equations, right? So the research object can be an individual body, local parts, or the whole system. We have learned that for each body, 3 equilibrium equations can be written, right? Once again, 3 equilibrium equations can be written. And so the whole system of the bodies have 3 n equations because we have n part. Actually, this n part should eliminate the frame, because frame never move. So actually, n is the number of bodies that can be moved in the body system, right? So therefore, if a body system consisted of n-rated bodies, the number of independent equations would be no more than 3 times n, right? I think these contents you guys can understand because each body will have 3 equations. We have n number of bodies, so there are no more than 3 times n, right? Correspondingly, the unknown quantities solved from the equations would be no more than 3 times n. Do you guys still remember we had talked about some determined problem and we talk about a statistically determined problem. That means we can solve all the unknowns. We also discussed that undetermined problem because we only have limited equation and the number of unknowns is greater than the equation we can give, right? So the general solution process is as follows. So please, guys, pay attention to and listen to me. So first, we should select appropriate isolated bodies. So we call that FBB, isolated bodies as the research object. In Chinese, I can show you guys. 选择一些个零件作为研究对象。And there are 2 ways to complete this step. So from the whole to parts, and from the parts to whole. And draw the force diagram of the above object. Draw the force diagram of the above object. And write appropriate or necessary adequate equilibrium equations according to the force analysis. Then solve the equation. So I do not support you guys this all information and just give you example directly, so you guys cannot understand. So that's true. It's my fault. No, so I hope you guys can reread this part of constant from our textbook, and then we will start from a very easy example to help you guys to understand this a little bit more. And we should just select the very simple example. If the example is very complex, we will just skip it, right? So let's see. We have an arch bridge, it's shaped like an arch, right? The arch bridge is made up of two parts, part AC and part BC, which are connected by pin C, by pin C. You can see this figure. The gravity every arch part is G and G. So maybe this is center of mass of part AC, and this is center of mass of part CB, right? Its gravitational force all 40 kilonewtons. There is a load, it is the active point, concentrated force acting on point F on the arch bridge CB, right? And its magnitude is F equal 10 kilonewtons. It let us determine the constraint force on point A, B, and C. So actually at A and B, it's about two constraints between arch bridge AC and frame, and between arch bridge BC and frame. And another point C is the pin, which connected part AC and part BC, right? So it let us determine the constraint forces on the point A, B, C. So this is a typical and simple system. Can you guys understand that?
Yes,
Can
Logic.
you?
Yes.
Okay, okay. Thank you for your reply. So let's continue, right? Let's continue. So we will look the solution first, and then we will look the force analysis. So the step one, we will study AC. You see, when we say select AC to be an object to study, you see, we should think that we free this AC from this whole system, right? Actually, it has a constraint at point C and point A. So we should first remove these two constraints. Second, we should give the reactions accordingly. You see? So that's the force analysis of AC. So because there is the fixed, there is a fixed support at point A. So we have FAX here, right? We have FAX here and FAY here. So we just use these two reactions to denote the action from the frame to the arch bridge AC. And we also free AC from the whole system. We use this FCX and FCY to denote the action from BC to AC. So this is the gravitational force of this part. So we just leave that at the original point. So can you guys totally understand the force analysis of this part? Can you guys understand
Elijah.
me? Okay, that's great. That's great, right? So actually, we can give the equilibrium equations from these 5 forces. But before that, we can just talk about the force analysis of part BC, right? So once again, if we try to give the force analysis of this part BC, we once again think about, we free this one from the whole system. You guys always should remember that this process is consumption, not for real, right? It's just consumption. So we assume that we just free this part from here to here. You see, actually we only need to remove two constraints at point C and point B. So because at point B is constrained between frame and part BC, it is a fixed support. So we give FBY, you know, we give a FBY here, FBX here, just to denote the action between the action from the frame to part BC. And when we consider the force analysis of point C, we should think about action and reaction. Since we know this force is acting by part BC on part AC, so at the same point, it also should have some reaction force from part AC to part BC at the same point. So we give the FCY prime, which is opposite direction from this FCY. And we give FCX prime, which have opposite direction with this FCX. And these two force analysis tell us, actually, we know that FCY, its magnitude equal FCY prime. You know, that's very hard for me to write something on the screen. It's very hard. We just use my mouse, you know, it's very small. I have a pen, but I cannot use this to write something on this PDF. And it also have a relationship. We have FCX equal FCX prime. Okay, so that is all the force analysis about. And the fourth one actually, when we try to select the whole part to be studied, you know, so this time we just think we will free this AC and BC together from the frame. So we remove a constraint at point A, so we give FAX, FAY, which will equal to this FAX, FAY. And we also give FBY and FBX, which will equal to this, right? This time we do not need to give the force because we select these two parts as a whole to be studied. So this will be internal forces we do not need to consider. See? Can you understand that? So sometimes the forces are exploded, and sometimes some forces are concealed into because it's reaction, internal reaction from one to each other. It will counterbalance, so we do not need to consider that. So this is quite important concept. You guys should know that. So maybe we can find, so first step, we study AC. That means we select AC to be studied. Then we draw the force diagram. We call that FBD, right? FBD. So actually this force diagram called FBD means free body force diagram, right? So this is force analysis of part AC. So before you give the equations accordingly, you should give this force analysis first. You know, So you guys can, I hope you guys can totally understand this because it's not difficult to understand, right? So then we can give the equilibrium equation. Why should we give that? Because we know this one is known, right? And this one, the four things we don't know. So actually, we can only give three equations. So we have sigma fx equals 0. Maybe I can cut this picture. See? We can cut this picture. And I can open it, move to this here, right? So it will help you guys see the picture and give the equations. You see? So when we give the equilibrium equation like sigma fx equals 0, we have fvx, right? And fcx, but fcx actually its direction is along the negative direction of x direction. So we have fvx minus fcx equals 0. That is equation 1, right? That is equation 1, right? And the second, sigma fy equals 0. So we have fay plus, because fcy also along downward direction, which is opposite to the positive direction of y-axis. So we have fay minus fcy minus g. This is the gravitational force acting at point D. It's along the negative direction of y-axis. So we have the second equation here. And we also give the third equation. We select point C, sigma MCF. So we only need to consider these three forces. So we have, you guys can see that Fx, its moment to point C, its direction will be counterclockwise direction. So we have Fx times 6. This is distance from point C to the action line of Fx. No, so we have this is 6. Our length is 6 meters, right? So we have 6 times Fx and Fey, you know, because it's action line along this direction. So its moment to this point C will be CW direction. So we have minus 6 times Fay. And we also have this G and its distance we can see here. You know, so this G, this T. So its distance from here to here is 5 meters. Can we see that? You know, so this is symmetrical. So because this distance is 1 meters, so this distance also should be 1 meters because this structure is symmetrical. 对称, am I right? Can you guys understand that? That's why this distance also should be 1 meters because the whole structure is symmetrical, right? So we have this equation. 6 Fax minus 6 Fay. And this direction tell us this moment of G to point C will along CCW direction. So I'm sorry. So this is 5 times G. So this is what? This is equation 3rd. See, this is equation 3rd. But unfortunately, the unknown numbers is 4. So we have Fax, Fay, and Fcx, Fcy. So we cannot get the result directly. How should we do this? So continue, we should study BC, right? When after we give these 3 equations, we cannot give and get all the 4 unknowns. But we can use the relationship. Which relationship? You know, because here FC, you know. So because these two forces and these two forces are two pair of action and reaction forces. So when we, according to this picture, give another 3 equations, actually we have 6 equations, but our unknowns only not 8 because 4. Here we have 4 unknowns. Here we also have 4 unknowns. 4 plus 4 equal 8, but these two guys are equal to these two guys. Actually, our unknown is 6. So we have 2 parts. We have 6 equations, and we have 6 unknowns. Then all the things can be solved, right? Right? So let's see. So once again, I will cut this picture for you guys to help you guys understand. I will cut this picture into our WeChat group and I will open it. So when we move the page, it will have the same. So continue. You guys pay attention to here. We study BC. We have discussed how we give is force analysis, right? This is BC. So we should give is a 3 equilibrium equation. Let us do this together. So first is the sigma fx equals 0. So we have fcx prime plus fbx. This picture is a little smaller. Can you guess? Can you guess? Sorry. I try to enlarge it a little bit. So can you guys see clearly? Actually, we have fcx prime here and fbx here. So we have these equation, right? And the second, sigma fy equals 0. So we have fcy prime plus fby and minus f and minus g, because we have another 2 active forces, f here and g here. So don't forget these 2 forces. And once again, we select point C to give the moment equation. So we have sigma mcf equals 0. So here you can see F have a moment to C with CW direction. So we have F times 3. That's why, because here is 3. The whole length is 6, and this length is 3, so this is 3. So this F is moment to point C, have a CW direction, and its magnitude should be 3 times F, right? So we have this minus 3 times F and minus 5 times G, because G have the same direction with F. So we have 5 times G with minus sign. And FBY here, it have opposite direction with these 2 forces. So it have CW direction with it, which is positive. So we have plus 6 times FBY, because the whole line, FBY here, FBY, no, the whole line to point C. So we have this. And another is 6 FBX. So actually FBX also have a moment to point C with CCW direction, also positive. So we have this. So maybe you guys still find it very difficult for you guys to understand all these things, but I hope you guys have a basic impression, right? So after we get these 6 equations, we have the relationship from the reaction and the action and reaction point of view. We can find the solution. So FAX, FAY, and D. So Since you guys have some problem to understand this, so maybe I will stop here and just talk something and give you just one homework. Hope you guys can finish that. And if you can't, you don't worry about that. Maybe next time, maybe 7 days after, right? We will do that together. So let us back to the slide. So let us do a very brief summary to this body system. So let's do a very short summary about today's content we have mentioned, right? So we should pay attention to the steps solving problem. So, once step one, we should select the body to study, right? And second, we should draw the free body diagram. We call that FBD. We call that FBD. Actually, we should give the fourth analysis in Chinese. We call that 受力分析. This is very crucial steps. 它是关键步骤 crucial 关键步骤 very crucial, very important 步骤. It's very hard for you guys to understand this character. Then, and step third, we should select the coordinates. Always consider the default coordinate. Firstly, we have X and Y and O here, right? A center and write down equilibrium equations. We always give sigma X equals 0, sigma Y equals 0, and sigma some point MAF equals 0, right? So that's the steps to solving problems. And solve the equations, determine the unknown quantities. So if we are lucky enough, we can find actually equations numbers is equal to the unknowns. So we can just use the equations to find the answers. And the second is the skills of solving problem. Choose coordinate axis to perpendicular to unknown quantities and choose given center of the forces at the point of crossing. So since we finished our summary, let us back to our examples. So I hope you guys can back to here to really think about the example we have talked about today. So you guys cannot understand this example because it is complex, but maybe after my introduction, you guys can look this example again. Maybe you guys can find this time you can understand that a little bit, right? So I hope you guys can research this example by yourself again, try to understand and try to read the textbook we just talked today. And actually I think to give you guys some homework, but maybe it's quite difficult for you, so I will change my mind. So you guys pay attention to me. We just select this example to be a homework today, right? Actually, we have talk about how to do this. So I only need you guys maybe use some your calculator to solve this 6 equation to find the correct result, right? I hope you guys can do this again, right? I think that's all for today. That's the only homework for you today, right? So
Okay,
see you
la师。
guys next time.
嗯
再见，大家。那么我们今
，OK，
天就
thank you，老师。
好的，我们今天就讲这么多，拜拜，
再见
拜拜，拜
拜拜
拜。Okay, I'll close the meeting.